Hey everyone, we're Alex and Rajat, and we're going to talk to you today about CPACT. It's our cloud processor accessibility compliance tool, and we're going to tell you a little bit about why we built this tool, and also talk to you about how this accelerates a lot of our OCP, GPU, and CPU hyperscaler efforts. So let's get started. We decided to build CPACT because of one big issue. Integrating multiple vendors and suppliers' CPUs is really tough, especially when we look at the key areas of debug, diagnostics, RAS, and impactless firmware updates. And what's interesting is that these differences aren't differentiating. Instead, they add a lot of complexities, they add a lot of time, and they add a lot of engineering effort to really enable the hyperscaler to integrate those new features. So we said, hey, how can we work together as an industry to fix that? And that's where CPACT and our workstream came out. It's all about working collaboratively between hyperscalers and CPU suppliers to identify the pain points that are common across us and then define the clear requirements and workflows that allow us to work better as an industry. And it really takes a whole community to work on this together. So we have a broad coalition across AMD, ARM, Google, Intel, Meta, and Microsoft, all working together through OCP. And this momentum allows us to really understand different kinds of end user scenarios, and it allows us to build really specifications that are future-proof and that are resilient across the industry. So CPACT starts off with impactless firmware updates. That's the first area we're targeting, and that's really when we look at impactless firmware updates as an industry, that's really thinking about how do we update a system in a non-impactful way, so without requiring a system reboot. Usually we have agreed upon doing the update step within 100 milliseconds. And the reason why this is so important to us as a group is because we need to have frequent updates across our fleet to be able to maintain high security and high performance. But doing those updates in an impactful way where the system reboots leads to a lot of pain points. Those include things like downtime, or that could be performance blips as well. Also, managing and coordinating those updates across a broad fleet of multiple suppliers is really tough. And sometimes you might need an update right away, and you can't wait for their upcoming maintenance window. So that's really where our impactless firmware update solution comes in and helps us as hyperscalers and suppliers build a better solution. We've decided to standardize this in both an in-band and out-of-band way. And we're standardizing this across three main phases. The first phase is live today in our specification, and that's the silicon vendor firmware, right? The second phase is microcode. So how do we update the microcode in an impactless way? For that one, we have the initial thinking, and we're working on really ratifying that and getting that ready as well. And then finally, we have the third phase, which is the privileged runtime firmware, which we're looking to update impactlessly as well. So that's the first area CPACT is targeting. The second one is debug, RAS, and diagnostics. All of us across the industry, whether hyperscalers or suppliers, really care about this space, right? It allows us to deliver the best uptime to our fleet, and it allows our customers to have the best possible experience. So we really want to have all these features integrated into fleets as quickly as possible, but it's tough because every single different supplier has their unique features, right? One supplier might build crash dumps in one way, a different one might have them in an entirely different way, and same with scan dumps or trace logs. So we said, hey, we need to be able to have one aligned standard across all. So our solution really standardizes two main workflows. First of all, we have the debug workflow. So for that one, we're thinking about three main steps. We have the monitoring phase. So that is looking at what are those error symptoms that are happening on the system that we can monitor for. The second one is configuring. So how can we pre-configure the system to best respond to those errors or those symptoms once we hit them? And third, we have collection. So how can we best collect what's happening on those systems so that we can root cause what went wrong and quickly get the system back online? The second standardized area that we worked on is diagnostics. And here we have three main pillars. First of all, we have the environment. So what are the how can we standardize the environment? What are the dependencies that are needed to run the diagnostics tools? Second of all, are the tools. So how can we configure and set up those tools in self-packaged way so that they're modular and can be used across different platforms. And third, we have the recipe. So this is the diagnostics recipe. How can we create a recipe that has a standard input, standard step-by-steps, and then finally a way to get the output and correct actions that you can take to successfully diagnose an issue. So together, these debug and diagnostics playbooks create a comprehensive way to resolve any issue that you're facing on your fleet. And we just touched like the very tip of this in this presentation today. Later on, you can learn much more about this whole effort in our session on advancing AI hyperscale quality. So stick around for that later today. So I've talked about those impactless updates, right? Diagnostics, RAS, and debug, and we've created clear specifications, and now we want to drive the industry towards them, and that's where our open source CPACT tool comes in. The CPACT tools enforces those requirements and allows everyone to understand how they can get their platforms working in compliance with them. And it really benefits the entire industry, right? On one side, you have the hyperscalers. The hyperscalers can benefit from this because they can onboard with confidence and ease. The second one is suppliers. Suppliers benefit from this as well because they're able to self-validate the platforms and features that they're building. They don't have to predict what their end customer or their hyperscaler might need. CPACT covers both x86 and ARM-based processors, so we want it to be inclusive of the whole industry, and it also provides multiple access methods, so doing it both in-band and out-of-band. And really what's important is that it allows us to move faster as an industry, so quicker time to market, and it benefits not only hyperscalers and suppliers, but the whole wider community. If we look at CPACT today, what's really important to us was that we built this with the OCP test and validation guidelines at heart, so from the ground up, that's integrated here. And we also designed it to support execution from within the target and externally from an invoker machine. We also provide flexibility and many different connectivity options, and the reason for that is it really allows us to apply it to many different data center topologies. Another thing to note of CPACT is that it has health check, and then it covers all those domains I listed. So it can cover compliance tests across them, and as a community, we can start contributing more and more to this compliance tool. And with that, we've covered about the background and CPACT, so I'm going to hand over to Rajat, who's going to talk to us more about how we apply CPACT to one key domain area. I think it's near and dear to a lot of people in the OCP TV community, and that is diagnostics. So Rajat, I'll hand it over to you.
Thanks, Alex. Okay, so as Alex pointed out, the tool follows the specification. Today, we were at 0.5 spec, and today we are now at 0.7 spec. Now, the key domain that was added from 0.5 to 0.7 was diagnostics. And we had to really discuss and understand how the industry is actually dealing with diagnostics for this. What you see here is there's typically a black box, a supplier-provided diagnostic tool, and then there is a documentation on how to use the tool. So imagine a hyperscaler who's trying to consume all of this, right? So all of you have probably got a lot of burn marks as a result of this. You probably take sometimes about 2 months just to integrate the diagnostic solution. Suppliers end up hand-holding hyperscalers for a good amount of time, and hyperscalers also end up finding some flaws in the documentation, leading to a lot of delay in integrating the diagnostics into the fleet. So we kind of broke down this problem. So imagine now, after standardization, we have 3 big pieces of the puzzle to solve, which will actually help integrate faster for the hyperscalers and also benefit the suppliers in providing the solutions. The first piece is that black box, the supplier's IP of the diagnostic tool. Now, we're still exploring ways on how we can ease the setup flows so that the hyperscalers can set it up with probably the use of containerized packages. This is one piece of the puzzle. The other piece of the puzzle is what we like to call the recipe. Now, this recipe, imagine this just to be a standardized schema-guided set of instructions, which tell you how to use the supplier diag tool and also generate what we like to call the diagnostic result codes, which are basically the error codes. So the recipe helps provide all of these as steps in a YAML file. And I'll get more to it next. But then there's also a third piece of the puzzle, and that's the map file. This map file, in a standardized way, will provide the dictionary of how to map the entire list of all possible diagnostic result codes from the supplier and the suggestive diagnostic actions when you encounter them. All right? It's not just the diagnostic actions. You probably have a bunch of other information like maybe the component of failure, probably instructions to the debug engineer, so on and so forth. All right, so let's build this picture a bit more, right? So you have all of these pieces of the puzzle on the left-hand side, which the supplier provides. The supplier also has the open-sourced CPACT tool to try out these collaterals. As reference, the CPACT tool gets the schema recipe, which today is at 0.7. Tomorrow we might probably have a new schema at 1.0, enhanced one. So it's a supplier hyperscaler handshake to decide which schema they want. Out comes a diagnostic report for the hyperscalers, so which helps provide two answers, which the hyperscalers typically have from the suppliers. One, are the supplier collaterals compliant? And two, do they work? Right? Two important questions which get answered with a single report. All right. I did promise you I'll dig a bit deeper into the recipe. So as mentioned before, it's a standardized schema-guided set of instructions on how to use the supplier diag tool. It may include even the requirements before they begin the execution stages of the diagnostic tool. And just like any other compliance scenario, this diagnostic recipe is also YAML-based, includes a header. The header could include the container information if you have any. And also, it'll be followed by a set of sequential steps, which could be one of three types. It could be a command execution step. It could be a log analysis step. Or you could potentially also invoke other scenarios. Imagine a nested set of recipes, right? Where you have a hyperscaler recipe invoking an integrator recipe, which in turn invokes probably a supplier-generated recipe. All of them written in a standardized way. But there's one key thing that differentiates a diagnostic recipe from a compliance scenario. Yes, they both run on the same CPACT tool. They both are using the same schema. But in a diagnostic recipe, you also provide means to extract or assign the diagnostic result codes. Now, in your log analysis step, you are basically, as I said, in the supplier diag tool, will generate a log of, we're not creating any boundaries around how the log should be from the black box. But the recipe provides means of how to exactly extract the list of all the diagnostic result codes. You see in the area there, we already have a bunch of sample recipes out there. You can take a look at it. You can just do a Python -- list, and you'll get the full list of recipes. What you'll also find is these recipes are, in the log analysis step, they will have varied ways in which you can use different regular expressions to extract these DRCs, which is what CPACT does. It consumes these recipes, executes them, and generates a list of discovered DRCs on the system. OK, so it's a YAML file, the recipe. YAML ain't a markup language. We had enough of those jokes. And it's easy, actually, to read a YAML script, right? But sometimes we want to ramp up our engineers to start building these recipes faster, right? Speed is the essence. So you have three options. You already have a bunch of recipes out there, which you can use for reference. Or you can use Microsoft GitHub Copilot. It'll automatically just provide your intent. It'll automatically generate a list of the entire set of steps in the right sequence. But yeah, AI can hallucinate. So you have the third option. And that's what we built in here. It's a recipe creator, a GUI-based schema-guided tool that will help you ensure that whatever recipe you have indeed works. It does let you import any existing recipes, so that makes your life easier. It calls out the required fields. It supports even recipes that require Docker images, because some of the steps may specifically say, I want to utilize this particular Docker image. It also has an inbuilt script verifier, which is in addition to what we have as a schema checker. And finally, once you're done with everything, you can export it as a YAML recipe or a JSON recipe. And yes, CPACT does allow you to run both YAML and JSON recipes. if you're interested. We'd like you to stick to the YAML one. So go online. You can actually, this is already ready. You can try out this scenario creator, and you can let us know what it's missing, and that's what we're looking for. That, and also contribute to the spec, right? If you can help provide feedback through CPACT tool, you can provide suggestions as to you wish to see all of these ways in which you can build a recipe. It's already out there in the open source. So looking forward to your contributions. But I would like to also call out two things. One, there have been many folks who have tirelessly worked on getting this fast up and ready. Just as I said, diagnostics has always been a burning subject. So we've been wanting to see something tangible early, and we already have it there. So I'd like to thank them, first of all. Second, check out those two specifications. As Alex mentioned, we have a session later today in the Hardware Management Forum. And we had one session yesterday on the CPU impactless specification. With this, I would like to open those mics for questions. Thank you.
Any questions for Alex and Rajeet?
First of all, thank you so much. I know you guys put soul into this work stream, and yeah, I just want to say thank you. I know you. I can ask you.
Thanks.
Thanks, Rama.
So how can we go beyond CPU debug?
Go beyond
Yeah. Other interfaces,
other interfaces.
like
So
PCIe and so on.
you're looking at the diagnostics piece
Yes.
specifically?
Absolutely.
Yes. So the diagnostics piece has been built to not be CPU centric. It's been you can target a GPU, you can target any of the components. So imagine this: if you're a hyperscaler, you have so many suppliers out there, each of them providing you their own diagnostic tool. You want everybody to speak the same language. You don't want to spend time integrating every one of them. This specification, this standard, this tool, all of these will help you get there.
Get them to align with this. How do you get the suppliers to align with this?
Yes, so it does benefit the suppliers, as we said. Today, they are indeed they're also facing some burn marks on themselves, right? They are spending time hand-holding the hyperscalers. We believe that this will benefit them immensely. Not just that. If you think about a diagnostic tool, end of the day, it's a wrapper or on a wrapper also, right? So CPACT recipe building itself can eliminate some of those layers of wrappers. It will actually help them build their diagnostic tool and also let us consume it better as hyperscalers. You had something to add to that?
No, I think that was a really good question. I think Jixon brought a good question. Another thing I would say to that is, as soon as we said, hey, we have this compliance tool, we had one of the silicon vendors in our group come up and say, hey, we have all these tests we run already, and we'd love to contribute them to your test suite. So I think we have that engagement, and I think in a matter of months, we're going to really build this out pretty quickly.
Thank you.
Yeah, just one last question. Do you guys have a compliance program for CPAT?
Sorry?
Are you guys looking to actually have a CPAT certified or any program which actually puts teeth to it? Because without teeth, usually vendors don't line up because they need to actually have a brag moment for that. So is there a plan? Because this is suggestive. This is very good. This is suggestive. But you need to go beyond suggestive for someone who has been having their own diagnostics to actually sort of fall back into common method. That's exactly what you was talking about. So is there something you guys have plans to move towards that? Because OCP could be a great forum for doing something.
Yeah, I think first of all, we really strongly contribute to the OCP test and validation work group. So that's the first one. And then we want to work hand in hand with the specifications that all the suppliers are contributing to, and the CPACT should really match those specifications, whether they're the CPU impactless updates, RAS, debug diags, or the GPU specifications as well. We kind of want that to feed into CPACT and CTEM. Rajat, what do you think?
Yeah.
I'll just add to what he was saying. There's a tool from Microsoft called WHQL. Can we enforce that?
Yeah, if that's our goal. That's like our North Star, to be able to get that get that maturity of a vehicle suite, right? That'll be awesome. We're still at 0.7. We want to capture all of what you said. And yeah, looking forward to that.
Thank you.